Sure. All right. Shame. I'm sorry, Narisha, but it's okay. That's why I'm here, to help you get a lot better. All right. So let's start with this equation over here that we've been given. We're going to start with this one. It says here, solve for x if 7x over x squared plus 2 minus 5x is equal to 3 over x plus 1. Now, let me ask this question, guys. If I had given you guys 7x over x squared plus x minus 5 over x, and I said to you guys, simplify, what would we do? What is the first thing that we would do, guys? If I gave you guys this equation, how would we solve? Correct, Abu, that's it. We would definitely have to look for a lowest common denominator. But before we do that, what would we do first? Correct. Sure, Abu, killing it, killing it, killing it. Yes, absolutely. We would first have to factorize Khulani, absolutely. The bottom over here, we would find an HCF, right? So we would then say 7x, and then we would factorize out an HCF of x, and we'd get x plus 1 minus 5 over x, right? And then our LCD would have to be x and x plus 1. Give me a thumbs up. Does everybody understand what ma'am has done here? Yes? Are we all okay with that? Cool beans. Excellent. All right. So we're going to do the exact same thing with our fractions. It's just that the difference here is that there's an equal sign in between. So we're going to look for the common ground between all three fractions. All right. So we're going to start with this equation here, and we're going to factorize the denominator. Right. So I'm going to factorize the bottom. I'm going to get 7x over x into x plus 1 minus 5 over x is equal to 3 over x plus 1. Right. Now, if I look at all three of these, my LCD is going to still be x multiplied by x plus 1. All right. I also need restrictions. Who remembers? What are my restrictions here? Correct. That's it, Fulani. X cannot equal -1, or x cannot equal what? There's another one. X cannot equal. That's it. Correct, correct, correct. That's it, Eric. That's it, Emmanuel. Well done, Abu. X cannot equal 0. Right? X cannot equal 0. Now, somebody had asked me in the question, in the lesson when we were learning about restrictions, ma'am, why do we need these things? Now, look at this over here. Look at what we've got over here. Over here, we've got two equations with an equal sign in between. So if I solve for this and my answer happens to be -1, if I go back into this equation and I sub in x as -1, I'm going to have problems. And if I get that x is equal to 0 and I sub in x is equal to 0 back into my original equation, I'm going to have problems. So that's why we do restrictions. When we get to equations, restrictions are very, very important, because if we end up with that answer, then we won't be able to find the answer we're looking for. All right, so, all right, I'm going to note that this first part over here isn't missing any part of my denominator. Correct, Abu. Right, so I'm just going to write 7x over x times 1 minus, now this part over here, if I have to put it over x plus 1 or x times x plus 1, you're going to note that an x plus 1 is missing times x plus 1, right? And whatever I do to the bottom, I'm going to have to do to the top as well. So I'm also going to multiply the top by x plus 1. But Abu forgot that there's a negative in front of that x. So this isn't actually 5 times that. It's actually -5 multiplied by x plus 1. Did we all forget that there's a negative in front there? Do not forget, guys, that there's a negative in front of the 5. Therefore, that becomes -5. All right. That's it, Abu. Aha. All right. And that is going to equal to, that equals, now over here, I'm missing x. I need to multiply by x. So I'm also going to multiply the top by x. So I'm going to end up with over x times x plus 1 And on the top, I'm going to get 3x. Now, here is the nice thing about equations with fractions. If my denominators are all equal, then I can drop my denominators and I can just make my numerators equal to each other. So I can actually rewrite this whole equation just with the top. I can just write 7x minus 5 times x plus 1 is equal to 3x. And I can just drop the denominators. Yes, abandon them. Abandon the denominator. Right. And then we're just going to solve for x. Okay, first thing I'm going to do is I'm going to get rid of brackets. I'm going to multiply that in. I'm going to get 7x minus 5x minus 5 is equal to 3x. And then I'm just going to move everything with an x to one side, anything without an x to the other side. So the -5 must go to the other side to become +5, and 3x must come to the other side and become -3x. Right, so I'm going to get 7x minus 5x minus 3x is equal to +5. 7x minus 5x will give me 2x, minus 3x is -1x, or just -x, and that is equal to 5. Narisha, we didn't mean it like that. We didn't mean it like that. We just meant it did its job. That's all we meant. Now you're adopting it. All right, so I don't actually want -x, guys. I want just x. So I'm going to divide both sides by -1. Okay, and those two. Or, I mean, Narisha's now making me feel bad. I'm not a user, you know. I'm not a user. Now you make me feel bad. I know, I know. Okay, sorry, guys. So, okay, I apologize. I apologize for using the denominator and just throwing it away like that. I'm sorry, Narisha. I didn't mean to. Okay, all right. Okay, let's look at number 1 over here. Let's look at number 1. Thank you. Thank you. All right. If we look at this question over here, guys, let us start by factorizing. Are we going to factorize? Correct. We're going to factorize the top instead of the bottom in this next question. And Fulani is right on brand. The top is actually a trinomial, so we're going to substitute in. But before we even go there, what can x not equal? What is my restriction? X cannot equal what? That's it, Fulani. That's it, Emmanuel. Good. X cannot equal -1. In this case, 0 won't matter, Emmanuel, because my denominator doesn't have 0. So, Abu, remember the denominator is not the, the numerator is not the thing we're worried about with restrictions. Only the denominator is. So, X cannot equal -1 only. All right, the numerator can equal whatever number it wants. It doesn't really matter. The denominator is what defines or makes an equation undefined. All right, so let's go ahead and factorize the top. It's a trinomial, so I'm going to open 2 brackets over x plus 1. And if I factorize that, I know I'm going to get x over here and x over there. I need factors of 3 that are going to give me -2. And I know I'm going to get 3 and 1, but now which one of them is going to be negative? I need -2, so I must have +1 minus 3. Okay, and this will equal to 0, right? But now, because I've got an algebraic fraction, do I see anything in common that I can cancel and cancel? Correct. That's it. Absolutely. The x plus 1s can cancel. Good. So I can cancel x plus 1 and x plus 1. And really, guys, my handwriting could be better. I don't know what's gotten into me. So my final answer then reads x minus 3 is equal to 0. Therefore, x will equal 3. That's it. X is equal to 3. Well done, Lulani, Abu, and Emmanuel. Excellent work. All right. Are we all okay with this idea? Good, good, good. Excellent. All right. Let's look at this next question over here. Whew. Tricky, 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 tricky. All right. So I've got two options here. What's my first option in number 2? That's it, Hulani. Yes, Narisha.
Ma'am,
Yes.
I kind of forgot what restrictions are again. Can you please explain?
What? Sorry, restrictions. Oh, okay. Restrictions, absolutely. I'm happy to explain restrictions again. All right. I will show you with this exact example that we've got here. Oh, actually, let me make it an easier one. All right. So if I have any fraction, right? If I have a fraction, let's just say 6 divided by 0. What's the answer there? 6 divided by 0 will give me what? Correct, Abu. It would give me an undefined value. Correct. I will get undefined, right? It'll be undefined. So we know that 6 cannot equal 0, right? Or sorry, the denominator cannot equal 0. So if I then put this as 6 over x, what can x not equal? X cannot be equal to what? No, it can equal -6, because if I get 6 over -6, I'm just going to get -1 as an answer. Correct, Narisha. X cannot equal 0, right? X cannot equal 0. Otherwise, I'm going to get 6 over 0 again. Okay, am I making sense, Pulani? Yes? All right, good. So now, the problem is when we have the whole denominator as an answer over 0. So now if I do this, if I write 6 over x minus 1, x can be 0. Because if I make x 0, I'm just going to end up with 6 over 0 minus 1. That's just the same as 6 over -1. That is -6. That's not going to make a difference. But if my whole denominator is then to become 0, what can x not equal? X cannot equal what? What would make my denominator equal 0? Which number? Not -1. Remember, Narisha, if I put -1, I'm going to get -1 minus 1. Okay, Khulani, if I make it 0, I'm going to end up with 6 over 0 minus 1. And that's just going to give me 6 over -1. So which number is going to make the whole of the bottom equal to 0? Which number for x is going to make the bottom equal 0? Correct, Nonka, you are 100% on point. X cannot equal 1. Because the second I make x equal to 1, my denominator is going to become 0. I'm going to get 6 over 1 minus 1, which is going to give me 6 over 0. Okay, so let's say, for instance, I then do this. If I say I've got 5 over x minus 3, what can x not equal? What is going to make my denominator equal to 0? X cannot equal 3, correct, that's it. X cannot equal 3 because then my whole denominator is going to equal 0. Okay, so if I then have x plus 2, x cannot equal what? That's it, Princess, correct, Abu. That's it, Kulani. X cannot equal -2, otherwise the whole bottom, not the whole bottom will become 0. Okay. Narisha, I hope that answered your question, my darling. Is that okay? Excellent, excellent. All right, let's have a look at number 2. Now, Hulani says we should distribute, and I kind of agree with her. Let's start by distributing this 3 into this bracket over here and taking it away. So I'm going to end up with 3a squared plus 3 plus 10a over 3a plus 1 is equal to 1. Now, I know that the top is actually a trinomial. It's just written in the wrong order. It's written in the wrong order. So let's rearrange it a little bit so that it looks like a normal trinomial. So I'm going to get 3a squared plus 10a plus 3 over 3a plus 1 is equal to 1. Now, because I have a trinomial, what can I do with that trinomial there? We can factorize, right? So I want you guys to factorize that for me. Remember, when we have a number in front of a squared that's not 1, we're going to have to use the cross method. Okay. So over here, I'm going to put all the values of 3a squared. And over here, I'm going to put all the values of 3. Right. Luckily for us, we know that the values of a squared are just going to be a, and the values are going to be 3 and 1 over here. Again, the factors of 3 are just going to be 3 and 1. All right. So what are we trying to get to? We're trying to get to 10a. 10a is what we're trying to get to. So in the end, we want equals 10a. Both of these added together must give us 10a. Now, let's cross multiply. I'm going to get 1a times 3 will give me 3a, and 3a times 1 will give me 3a. Now, that's not going to give me 10a. It's not going to give me 10a. It's not helping. So what I can do is maybe switch these two around. I can put 1 there, and I can put 3 there instead. And then let's multiply. I'm going to get 3a times 3 will give me 9a. 1a times 1 will give me 1a, and indeed 1a plus 9a will indeed give me 10a, right? So I know that in my two brackets, when I'm factorizing, I'm going to put those two together, and I'm going to put those two together, and I need them both to be positive, because positive 1a plus 9a will give me 10a. So that one must be plus 1 and plus 3. So in my brackets up top, I'm going to have 3a plus 1 and a plus 3 over 3a plus 1 is equal to 1. Do I see anything top and bottom that I can cancel? Yes, I do. I see the 3a plus 1. Right, so that one and that one will cancel. And now my question just reads, a plus 3 is equal to 1. And then I can solve for a, right? I can solve for a. And I'm just going to go a is equal to 1 minus 3. Therefore, a is equal to -2. All right. Thumbs up, thumbs down. How are we feeling about that? All right. Princess is feeling okay about that. Khulani is feeling okay about that. Emmanuel's like, okay, that's fine. Let's have a look at this one over here. All right. Okay, now this one doesn't have anything for us to factorize on the top, right? But I can factorize the denominators, yes? Good, that's it, Khulani. We need to find an LCD. So please go ahead and factorize the denominator for me and find me an LCD. Good, well done, Abu, well done, Emmanuel. Good stuff, that's exactly what we're looking for. That's it, Princess. All right, good, we know that. Remember our default setting, guys. Always check for HCF first. I know that I can factorize that by taking out an HCF of x. So I'm then going to end up with an LCD of x and x minus 5. What are my restrictions? What are my restrictions? X cannot equal 5, and x cannot equal what? What else? That's it, Eric. Good. Yes, absolutely. Not 0 question mark, 0 exclamation point. Because what happens over here if x is equal to 0? I'm going to get an undefined term in the middle of my equation. So x cannot be equal to 0. Right. Undephones. Yes, correct. It is undephones. All right, good. So we're going to go ahead and give each of these their own denominator, x minus 5, minus, all right, let's start with the first part. I'm missing an x over here. So I'm going to multiply the top by x and I'm going to multiply the bottom by x. So at the top over there, I'm going to get 4x. Now, guys, remember there's a negative there, so this becomes minus 10, right? So on the top, I'm going to have minus 10. Now, at the bottom over here, I'm missing an x minus 5. So I must also multiply the top by x minus 5, right? Minus 10 multiplied by x minus 5 over x times x minus 5. And I know that if I factorize that, I would get x over x minus 5. So I don't have to do anything to the top on this side. So I'm just going to get 2 over. If that factorizes, I'll get x and x minus 5. And Narisha, I'm going to apologize in advance for abandoning the denominator, please. I'm very sorry. I apologize in advance. I'm going to abandon our denominators. I feel so guilty now. Narisha, you've made me feel like a criminal. Okay, I'm going to, I'm sorry. So on the top, I'm going to get 4x minus, now over here, I need to sub in. I need to distribute in. I'm going to get minus 10x plus 50 is equal to 2. And then I can solve for x. I just need to take that positive 50 over to the other side. 4x minus 10x will give me negative 6x is equal to, well done. Thank you, Narisha. Okay, I'm going to get 2 minus 50 on this side, and that's going to give me negative 48. And then I'm just going to divide both sides by negative 6. And I have somebody who DM'd me the answer way before any of you. Well done to that person. They know exactly who they are. Right, well done. Therefore, x is equal to 8. All right. Okay, I kind of like this. I feel like it's nice and stuff. It's quite easy to do, you know, because we've already done algebraic fractions, and then it just translates quite nicely because we've already done them. And it's really, yeah, I like it. I like it. All right. Let's talk about simultaneous equations. All right, I want you guys to give me a thumbs up in the chat if you've already done simultaneous equations at school. And give me a thumbs down if you have not. I'm just going to switch on my light quickly. Okay. All right, so I've got quite a few thumbs up. Vukosi says no, thumbs down. Okay, that's okay, Princess. That's why we're here. That is exactly why we're here. Nonka says no as well. Yes, we will, Emmanuel, we will. If you, oh, I don't think, guys, I'm very bad at updating the calendar. I will update the calendar. I'm very sorry. I will do it. I will let you guys know exactly when we're doing it. If you check the MathsLive, calendar after today's lesson, I will have updated the calendar. Okay, I'm very sorry. I'm quite bad at that. I've just noticed. Sorry, guys. I will make sure I get it done. All right. So we're going to start literal equations on Wednesdays. On Wednesday. All right. On this coming Wednesday, we're going to do literal equations. All right. So when we solve for simultaneous equations, who can tell me what does the word simultaneous actually mean? Who knows? What does the word simultaneous mean? That's it. Correct, Emmanuel. It's when something is happening at the same time. That's what simultaneous means. At the same time. It's because somebody wrote, I don't understand substitution. Now the next word that came out of my mouth was at the substitution. At the same time. Okay, good. It means at the same time. So we're going to be looking at two different methods that we can use to solve for simultaneous equations. Now, I'm going to teach you guys the substitution method first. So, Hulani, you're in luck. And then after that, we're going to look at elimination. So, first thing we're going to do is we're going to follow a set process. All right. Narisha, I don't know. It's not me, man. It's the mathematics department. It's not me. I blame George Maths. When I don't know who invented things, I just call them George. So I blame George Maths for harder things. Okay. Blame Mr. George Maths. When I couldn't remember who invented the TV. So in my exams and my tests at school, I used to just write Mr. George TV. And then they'd be like, who invented the telephone? Mr. George telephone. And my teacher used to get very annoyed at me. But I used to do that all the time. So who are we going to blame for hard things? We're going to blame Mr. George Maths. All right. Okay. All right, let's start with substitution. Now, well, not really, Abu, but okay, we'll take it there. We'll say okay. All right, first thing we're going to do, guys, is we're going to number our equations. So I'm going to go to these two equations I've got over here, and I'm going to go y is equal to x plus 4. I'm going to name that equation 1. And then y is equal to negative 2x plus 1. And I'm going to name that equation 2. All right, so now with these two equations numbered like this, I know that what I actually want is one of them to either equal y or one of them to equal x. Now, I can see over here that equation 1 already says y is equal something. Well, in this case, Lulani, we don't have to because y is already the subject of the formula. All right, y is already the subject of the formula. So that's what we're going to use. Okay, so here's what I'm going to do. I'm going to say, we're going to substitute equation 1 into equation 2. So what this means is I'm going to take equation 2, and in equation 2, wherever I see a y, I'm going to replace it with x plus 4. That's what that means. Okay. So I'm then going to say y is equal to negative 2x plus 1. Right? But I can see that there's a y here. So what am I going to replace this y with? Emmanuel, that step is not necessary, and I'm going to explain why it's not necessary. Okay, not in this particular case. Good, guys. I'm going to replace the y part with x plus 4. Okay, so my equation will then read x plus 4 is equal to negative 2x plus 1. All right, and now we can just solve for x. So I'm going to leave that up to you guys. Solve for x for me, please, and tell me what x is equal to. Princess says negative 1. I want to see if everybody's in agreement with you. Okay, great. Okay, so I'm not going to go through the motions. I think we all know how to solve for a linear equation. It's not that deep. So this means that x is then equal to negative 1. Some things happened, we did so many things, and x is equal to negative 1. But we are not done because the question wants us to solve for both y and x. Now, right now, we've only got an answer for for x. So I'm going to then go back into equation 1, and I'm going to sub in what x is. So I'm going to have y is equal to -1 plus 4, and therefore y is equal to -1 plus 4 will give me 3. And there we go. We have both answers. All right. Give me a thumbs up. Are we okay with how to use substitution? Are we all okay? Excellent. All right, I'm seeing somebody with still a thumbs up, thumbs down. That's okay, Norisha. Let's have a look at another example. All right. I want you guys to have a look at number 1 over here. Now, if you already know how to solve number 1, go ahead. Yeah, okay, Emmanuel. Listen, I don't think it's particularly necessary for us to do that, especially if you are just if you're just going to use the same thing again, because look at what's actually going to happen in this equation. All right, for those of you who know what to do, please solve for x and y simultaneously in question 1. All right, it's kind of redundant, Emmanuel, for us to say y is equal to x plus 4 and name that equation 1, and then write out the exact same formula, and then we would go y is equal to x plus 4 and then name that 3. These two things are exactly the same. They're exactly the same. So there's no need for me to name that one equation 3 and that one equation 4. They're exactly the same thing. So it won't make sense for us to now name them equation 3 and 4 when equation 3 is exactly like equation 1 and equation 4 is exactly like equation 2. Am I making sense? Okay. It will defeat the purpose, but I will show you when we do swap it out. Yes, that's it, correct. When we make something else the subject of the formula, then we name it equation 3. All right. You're very welcome. Hulani, please double check your answer for me. Oh, excuse me. Well done, Mbulelo. That's it. 100% princess. That's it. We're absolutely doing great, guys. Correct. All right, let's have a look here. First, we're going to do some numbering. So we're going to go y is equal to 3x plus 2, ... That's equation 1. And then we're going to say y is equal to 2x plus 1, ... Equation 2. So because I'm not going to rearrange anything, this thing is already equal to y. I'm just going to go substitute equation 1 into equation 2. So equation 2 is the thing that we're actually using. Equation 2. So I'm going to go equation 2, and I can see right off the bat, y is equal to 2x plus 1. Wherever I see a y, I need to replace it with 3x plus 2. So I'm then going to go 3x plus 2 is equal to 2x plus 1. And then we can do a little bit of moving things around so that things make sense. Okay, the 2x will go over to the other side and become negative 2x. The 2 will come over to the other side and become negative 2. So I'm going to get 3x minus 2x will give me x. And 1 minus 2 will give me negative 1. All right. And then we can go back and sub back into equation 1. I'm then going to have y is equal to 3 times negative 1 plus 2. That means y is equal to 3 times negative 1 is negative 3 plus 2 is negative 1. And those are the two values that we will get. Narisha, are we okay with this idea? Are we good? Excellent. Good. All right. Here's one I want you guys to try on your own. I'm going to give you exactly 3 minutes. Okay. X plus y is equal to 1 and x minus y is equal to 5. Now, Emmanuel, have a look at the question I've put on the screen. Do you see how we don't have x equals something or y equals something? Now we know that we're going to have to rearrange something. And that's where we're going to get the equation 3 from. All right. So I'm then going to go x plus y is equal to 1. That's equation 1. And x minus y is equal to 5. That becomes equation 2. Now I need x equals something or I need y equals something. So I'm going to take equation 1 and I want to make x the subject of the formula, which means I now need to take y over to the other side. Somebody's asking, ma'am, where you subbed x into y, do you have to specify that you're subbing x specifically? Like how you said you were subbing 1 into 2? Yes, ma'am, we must. Otherwise, we're just writing a bunch of things that don't make sense. We must. Okay, we must follow protocol. Okay. We must be like an honorable member in the parliament. We must observe protocol. Okay, we must label. We must tell them what instruction we are doing and then do it. Okay. Okay, good. Now that we're going to rearrange equation 1, I'm going to get x is equal to 1 minus y if I take y over. Now, do we see how that equation and this equation are two completely different things? They are so completely different to each other. They're not the same thing. That means we now have to take this new equation we've written and we need to label it equation 3. Right. Then we can say sub equation 3 into equation 2. Sub them in, right? That means I'm going to use equation 2, which says x minus y is equal to 5. Wherever I see x, I'm going to replace x with 1 minus y, right? Which means over there, I'm going to have to replace x with 1 minus y. So I'm then going to get 1 minus y is equal to 5. All right, and then I'm just going to take the 1 over to the other side. Negative y minus y will give me negative 2y is equal to 5 minus 1 is 4. And then we're just going to divide by 2 everywhere. Divide by negative 2, divide by negative 2. Therefore, y is equal to negative 2. I'm not done because I still need to find x. And I already know that I've tailored equation 3 to say x equals something. So I'm going to use equation 3. I'm then going to go x is equal to 1 minus, now I've got y, I know that y is negative 2, y minus negative 2. Therefore, x is equal to 1 plus 2, which is equal to 3. And there are my two answers. Y is negative 2 and x is equal to 3. All right. How did we feel about that? Are we all good? Not bad at all. Not bad at all. All right. Shall we learn about elimination? Like physics, it's not that bad. It's not that bad. All right, let's learn about elimination, guys. All right, I'm going to give us an equation that we can use for. That's okay, Tyler. We can come back and do another question, okay? May you please explain how we got negative 2? All right, so remember from equation 3, Fulani, okay, we said that we're going to sub equation 3 into equation 2. Now, equation 2 is over here. Equation 2 says x minus y is equal to 5. Now, equation 3 tells me that wherever I see an x inside equation 2, okay, inside equation 2, then I must replace it with y, 1 minus y. Now, if I look at my equation, okay, just give me a second. All right. Okay, so I'm going to then substitute in here. I can see there's an x. So I must take x and I must replace it with 1 minus y. So I'm going to get 1 minus y. Now I need to continue with the rest of the sum. 1 minus y is equal to 5. Okay. And then I need to add like terms. I've got minus y, so that's going to give me 1 minus 2y is equal to 5. And then I can take the 1 over to the other side. It's going to become negative 1. So I'm going to end up with negative 2y is equal to 5 minus 1, which is 4. And then we're just going to divide by negative 2 and divide by negative 2. All right, so y then is equal to negative 2. Hulani, are we okay there? Are we good? Good, excellent. All right, let's talk about elimination quickly, guys. All right, here's the sum that I'm going to give you. I'm going to give you 3x plus 2y is equal to 16. And 2x minus 3y is equal to 2. All right. Okay, I see Kulani saying HCF. And I'm not sure how your teachers have taught you how to do this one. Okay. Can I teach you guys my method? Is that okay? Can we work through my method? Correct. Okay, Emmanuel's like, name the equations. Yes, we're off to a great start. Good. Let's label our equations. Right, I'm gonna say, let me skip a line. 3x plus 2y is equal to 16. I'm gonna name that equation 1. And then I'm gonna get 2x minus, not plus, minus 3y is equal to 2. And I'm going to name that equation 2. Now, if we're looking at the idea of an HCF, name them John and Gary. Narisha. Okay, if you insist, John and Gary. I feel sorry for any John and Gary out there, but Narisha says I must name them John and Gary, and there we go. We must name them John and Gary. Okay, so here's what we're going to do, guys. I know that if I have to now make one of these the subject of the formula, let's say, for instance, we take equation 1, and we want to make y the subject of the formula. I'm going to get 3x plus 2y is equal to 16. I'm going to move the 3 over to the other side. I'm going to end up with 2y is equal to 16 minus 3x. And then I'm going to have to divide through by 2, divide through by 2, divide through by 2. And then I'm going to end up with y is equal to 16 divided by 2 is 8 minus 3 over 2x. Now, substituting in a fraction is going to look ugly. Nobody wants to do any of that. So we're not going to do that. Here's what we're going to do. I'm going to look at, correct, that's it, Emmanuel. We need to eliminate one of the variables. Now I'm going to take any two of these numbers. Let's take 3x and 2x, and we're going to look for the lowest common multiple. What is the lowest common multiple between 3 and 2? Correct. Yes, Abu. It's going to be 6. Right. It's going to be 6x in this case, 6x between those two, 6x. Right. So what I'm going to do is I'm going to take equation 1, or I'm going to take John, and I'm going to say equation 1 times it by 2, because I want my 3x to change to a 6x. So if I multiply that first part by 2, I'm going to multiply throughout by 2. So I'm going to go times 2, times 2, times 2. Now what that's going to give me, I'm going to get 6x plus 4y is equal to 16 times 2 will give us 32. And that becomes equation 3. Do not forget, we've changed the equation. So that becomes equation 3. Then I'm going to go to equation 2, aka Gary. And we're going to, if I want 6 over there, I'm going to multiply by 3. I'm going to multiply through by 3. So I must multiply by 3, multiply by 3, and multiply by 3. So I'm then going to get 6x, negative 3y times 3 will give me minus 9y is equal to 6. And that is going to be equation 4. All right, and as per the request, we're going to name this one Bob, and we're going to name equation 4 Harry. Nice. Nice naming, guys. All right. So what we're now going to do is we're going to note that if I subtract these two equations from each other, 6x minus 6x is going to give me 0. So I'm now going to say equation 3 minus equation 4. I'm going to minus each of them one underneath the other. So 6x minus 6x will give me 0. And then I'm going to get 4y minus negative 4y. Minus negative will give me plus. Is everybody okay with why ma'am did that? Are we all okay with why this becomes plus? Just let me know. Are we okay with why ma'am is saying plus instead of minus? Okay. All right. So over here, I've got a positive 6, right? And over here, I've got a negative 9. So if I say 6x minus positive 6, I know that a negative and a positive will give me a negative, right? Correct, Emmanuel. Now, that's for those two. 6x minus positive, a negative and a positive will give me a negative. Now, over here, if I go positive 4y minus negative 9y, what's going to happen to that negative and that negative over there? What are they going to give me? Correct. They're going to give us a positive 9y. All right. Are we all okay with how that works? So I'm going to get minus negative. That's going to give me positive 9y. So 4y plus 9y will give me 13y. All right. And that is equal to, now this one is also positive. So I'm going to get 32 minus positive 6. And that will give me 26. Correct. 32 minus 6 will give me 26. And now I want to write in red. 26. And do you see how now we've isolated y? And we can solve for y. I'm just going to divide by 13 on both sides. That's it, Emmanuel. That's it, Abu. Good. Then y will equal to 2. Y is equal to 2. Now that I have y, I can go back to either equation John or equation Gary, and I can figure out what x is equal to. I'm going to use equation 1, right? So in equation 1, I know what y is equal to. So I've got 3x plus 2. There's a y. I'm going to replace y with 2. So I'm going to get plus 2 times 2 is equal to 16. And then I can just solve for x. I'm going to get 3x plus 4 is equal to 16. Therefore, 3x is equal to 16 minus 4. That's going to give me 12. And that means that x is equal to 4. All right. All right, folks. Are we all okay with this? How are we feeling on a scale of 1 to 10? 1 being I'm struggling, ma'am. 10 being I'm all good, ma'am. Where are we sitting on substitution and elimination? Eric, you can, absolutely. But the reason why we need to learn both is because sometimes our teachers will specify. Our teachers will say, sometimes they'll say, use elimination. And then if you haven't learned elimination, then you're going to be like, uh-oh, like, what do I do now? What do I do now? Okay, so we need to know how to do both of those. All right. Okay, I'm going to give you guys another one. I want you guys to try elimination on this one. Okay, here we go. Let's not make it too easy. Okay, 3y minus 4x is equal to 7, and 5y plus 2x is equal to 16. All right, use elimination, guys. Take it away. I'm going to give you guys 4 minutes because the process is quite long. So go ahead. I know, Abu, I know. But like I said, sometimes your teachers are going to specify. So we need to know how to use both. So for this one, we're going to use elimination. All right, take it away, peeps. If you have any questions, pop them in the chat. If you have any answers, DM me. Don't pop them in the chat just yet. Just give me 1 second. Okay. Guys, remember, it's not necessary to always make x the subject or the formula. We can also try and eliminate y first. Okay. All right, peeps, we've run out of time, so I'm going to start on this one. Okay, so I'm going to first label, right? I'm going to get 3y minus 4x is equal to 7. That's equation 1. And 5y plus 2x is equal to 16. That's going to give me equation 2. All right, so it's not always necessary for me to make x the subject of the formula. In this particular one, I'm going to find the LCM of the y's of 3 and 5. Now, I know that my LCM for both of these will be 15y Good. So we can make y the subject of the formula. So I'm going to say in equation 1, I'm going to take equation 1. I need to get from 3y to 15. So I'm going to multiply equation 1 by 5. Equation 1 times 5. So times 5, times 5, times 5. So on the top, I'm going to get 15y minus 20x is equal to 35. And that becomes equation 3. And then for equation 2, I'm then going to multiply by 3 times 3. So times 3, times 3, times 3. So I'm then going to get 15y plus 6x is equal to 48. And we'll make that equation 4. All right. Now I can see that my 15y's can cancel if I eliminate them. Right. Okay. Just for Abu. Abu says I must name them Bob and Molly. There we go. We happy? All right. I'm then going to say equation 3 minus equation 4. Right. So I'm going to have 15y minus 15y. That is going to give us 0. And then over here, I'm going to get negative 20x minus positive 6. A negative and a positive will give me a negative. So negative 20x minus 6x will give me negative 6x. Oh, negative 26x. Hi, why am I lying? Negative 26x. And that is equal to 35 minus 48. And that will give me negative 13. Negative 13. All right, and then all I have to do to solve for x is just to divide by negative 26, divide by negative 26. Those two will cancel, and x will then equal, x is then equal to, the negatives will cancel, 13 divided by 26 will give me a fraction that will be 1 over 2. It's a bottom-heavy fraction, so not 2, 1 over 2. 13 divided by 26 will give us a half. All right, and now that I know what x is, I can go back into, let's take equation 1, and we're going to sub in what x is. Now, I know equation 1 says 3y minus 4x, there's an x, so I'm going to go minus 4 times a half is equal to 7. Bulelo, check again. 3y, and then negative 4 times a half will give me minus 2. Is equal to, oh, no, you're correct. You're absolutely correct. Sorry, Mbulelo. In my mind, the answer is 1. I don't know how I got that into my head. Right, and then the negative 2 will go over. So I'll end up with 3y is equal to 7 plus 2, which is 9. Therefore, y is equal to 3. Divide by 3, divide by 3. And there are our two answers. X is a half and y is equal to 3. All right. Okay, and that's where we're going to